Hello and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will go over a problem from homework, section 10.4. This is problem number 2. The question they're asking is the average time to complete an obstacle course different when a patch is placed over the right eye than when a patch is placed over the left? They say that they have 13 randomly selected volunteers to complete the obstacle course with a patch over one eye, and then completed an equally difficult obstacle course with a patch over the left. Completion times are below. Left means a patch was placed over the left eye, right means the right eye. So I'm just noticing that 1, 2, 3, 4, 5, 6, 7, 8. There are only 8 data sets, or not 13 of them. But that's okay. They ask us to assume normality, and another question, what can be concluded at the 0.10 significance level? And another typo here. Looks like they said significance a couple of times. Okay, let's answer that first question. For the study, we should use a t-test. So this is going to be 2 paired sample and t-test. So this t-test for 2 paired sample, which means we're going to be interested in combining the 2 samples together. And so as we combine the 2 samples, we look at what the claim is, or what they're trying to say in the statement in the question. Is the average time between the obstacle course different when you put a patch over the left eye? So the average when we patch over the right eye versus when we patch over the left eye, they're asking, is this different? So different means not equal to, and that would be our claim. Now, since this is a paired sample, we generally want the means together. So a little algebra where we subtract L, mu sub L from both sides, and then we're going to get 0 on the right hand side. And then this difference, mu sub r minus mu sub L, can be written as mu sub d, as in the difference between the 2 data sets. And so now we have ourselves a statement that is made for this paired t-test. Now, since this statement does not contain a condition of equality, we will look at this as the alternative hypothesis. Our symbol for that is H sub A, but sometimes we use a symbol H sub 1. So this is your alternative hypothesis, and mu sub D is not equal to 0 will be the alternative hypothesis, which means the null hypothesis will be mu sub D is equal to 0. Okay, all right, so now it gives us a t value, and from here we will use technology to find our test statistic p-value, and then allow us to make our conclusions depending off is the p-value bigger than or less than the significance level. Okay, so let's move to our technology side of things. Here is our Google Sheets, and in this template what we would do is we would put in the values for our sample. Now if this is a different problem with more or less data sets, we probably want to clear this all out and start fresh. And so in this particular case, I've inputted the values for the right eye, and then we would put the values for the second sample, and then from here we would subtract those 2. And all you need to do is do the subtraction for the first one. So A sub A3 is the first cell minus B3 the second cell, and then we're going to get that value. I'll press enter, and then from here we will click and drag to fill in the rest of this. Now as these cells get filled in, they will automatically calculate the mean, standard deviation, and sample size for the differences, for the pairs. Okay, Backtrack a little bit. Our mean mu, or mu sub d, is always going to be 0 for these paired sample calculations. And then our tail will depend on the alternative hypothesis. If it's pointing to the left, we're left tail. Pointing to the right, it's right tail. And if it's a not equal to, we would be at 0. And then our test statistic and our p-value will automatically be calculated. Our test statistic will be the difference between the mean from the paired data set minus mu. And then that will be divided by the standard deviation from the paired set divided by the square root of n. And then once we find our test statistic, our p-value will be computed by the t-distribution commands. And depending if it's a left tail, a right tail, or a two-tail test, they will have their appropriate calculations. Okay, so now that we have that set up, we just need to enter the data set. And our data set is given here. The right eye is already inputted, so now let's just put in the left. And now that we have that complete, let's just enlarge the screen again. We have our data, and we have the first number here, but let's retype this in. So let's clear that and say from here I want to hit equals. I'll click on that first element in the first sample, the minus sign, and then I'll click on the first element in the second sample, and I'll press enter. Here they suggest autofill. I think I'd like to control it myself, so I go back to the first cell and then I click and drag down until I finish the last one. Be careful not to go too far, because if there are zeros in this, they would also be part of the calculation. So if you automatically or accidentally go down a little too far, then your calculation changes. So you want to make sure that you stop at the appropriate n size. Okay, so we have this is going to be our new sample, the difference between the sample sizes. Again, the mean mu sub d is going to be 0. We are looking at a two-tail test, so we'll keep this at 0. The mean, the standard deviation, and the sample size was automatically calculated from the difference column here. And then our test statistic and our p-value, again, automatically calculated. So that's it. Those are our values. So let's put in our values for our results. We have our test statistic was given to be a negative 2.692774. Our p-value was 0.03096, or that would be 0.0310 if we want to be accurate to 4 decimal places. But I think they're flexible here if you put more than 4 decimal places. And so we can see clearly that the p-value, I'll say PV, compared to 0.1 is going to be less than alpha. And so since our p-value is less than alpha, we will reject the null hypothesis. Okay, so now that we've rejected the null hypothesis, we're saying that we're rejecting this null hypothesis here where mu sub d is equal to 0, so that means it must actually be different. So we're looking for statements that show that it is different. There is a statistically significant evidence to conclude that the population mean time to complete the course is equal to. So this is not it. I'm not saying it's equal to. The results are statistically significant, so evidence to conclude the population mean is not the same. So this is good. Let's check this, but let's read the others to make sure that they're saying different things. The results are insignificant. I don't think it's insignificant because we found some information about this, so I will cross this out as well. And then the last one, the results are statistically significant, conclude that 8 volunteers. So when they start including the population size for that particular sample, then you're sticking with that sample. But in the study of inference, we're always wanting to infer information and generalize the information to the whole population. So let's automatically cross these things out because that's not what the hypothesis test is about. So I think our winner is going to be the second choice. Okay, that's it. I hope that helps. Good luck.